Hi everyone, in this lesson we are going to represent linear equations. This video is supposed to act as basically a review for everything that you should know for our next upcoming unit, which is all about systems of linear equations. So some of the basic properties of a line, I've listed them here for you, which you should know. So in case if you don't remember, I'm going to go through them for you. So the first is that the first differences are constant, and I will show you an example of what that means in case you don't remember. We also know that the graph is a straight line, so that should be an obvious one. It's going to be straight. It's not going to be any kind of curve because then it wouldn't be linear. And we also know that the equation has a degree of 1. So a degree is just the highest exponent on a variable in an equation. So for example, I can give you this equation right here. And if I ask you what the degree is, you're going to look for the highest exponent on the variable. So if we look at the 7 here, this is a constant. So you know that there is an invisible x to the power of 0 here. We never write that because x to the power of 0 is 1. So it's basically like just saying 7 times 1. And you know in math, we never write the 1 because we know it's there. So this term right here has a exponent of 0, right? This x has a power of 0, so the exponent is 0. If we take a look here, the x has a 2, so our exponent is 2. And then this term right here, the exponent is 4. So the highest exponent, comparing all of these, is 4. So therefore, the degree is also 4. So that's all that's saying. And all we're saying is that for linear equations, the degree is always 1. So here, it's 0, the exponent is 0, and here, the exponent is 1, so therefore it's linear. So if I gave you an equation like this, if I gave you that, and I said, is this linear? Well, you would check for the degree, and you would see that this has an exponent of 1, and this has an exponent of 2. And the highest exponent is 2, right? So the degree is 2. So therefore, this is not a linear equation because its degree is not 1. So that's all that's saying, and that's something you should note. We also have two different equations to sort of represent this linear relationship. So the first one is the slope y-intercept form, and the second is the standard form. You're going to be working with these a lot, so get comfortable with them. One thing I do want to point out, though, is the slope y-intercept form is a very special kind of equation. And the reason why is because this unit is all about graphing linear equations and these lines. So this formula or this equation tells you a lot about the shape and how the line is going to look like if you understand what it's saying. And what I mean by this is, so this m right here in front of the x, this is not just any coefficient, this is a very important coefficient because this represents your slope. And your slope, what it means is it's the steepness of the line. So your slope is going to tell you how steep your line is and the directionality of it. So the slope is represented in sort of 3 different ways that you will come across. So the first is this typical notation, delta y over delta x. And this triangle symbol, this represents delta, which basically means change in. So all we're saying is that the slope is the change in the y values over the change in the x values. This can also be written in the form of y2 minus y1 over x2 minus x1. And you would have came across this formula if you were asked to find the slope given 2 points. So if I had given you 2 points and I said, find me the slope, you would use this formula. So for example, if I gave you 2, 3, and 0, 4, you would use this formula to find the slope. We're not going to use this formula that much in this unit, but you should know it. And then the last one, which is probably the first way you were sort of introduced to it is rise over run. So your rise is your change in y values in the vertical direction, and then your run is the change in your x values, your horizontal direction. So that's the slope. Another thing you should know is directionality is determined by whether or not this number is positive or negative. So if you were given positive 4x, your line is going to look like this. So it's going to start from the third quadrant here, and it's going to end on the first quadrant. But let's say if your slope is a negative number, so it's like negative 2x, your line is going to look like this. So it's going to start from the second quadrant and end at the fourth one. So that's something important to note. Another thing about this equation is that this b value, this plus b, this is your y-intercept. So this is where your line intercepts on the y-axis. So wherever your line intercepts on this vertical axis here, your y-axis, that's your y-intercept. If you take a look at the standard form equation, this is a little bit more complicated because it's not complicated, but it doesn't really tell you a lot about how your line is going to look like. You're going to have to do some rearranging and algebraic manipulation. So this is why this kind is very special in that sense. So graphing linear equations can be done in different ways. We can use a table of values, which is usually what you're taught growing up. 2 is the slope y-intercept form, which is this equation right here. The third is using the x and y-intercepts, and the fourth is a graphing calculator. So obviously on a quiz and test, you're not going to have a graphing calculator, but there are some really great ones online that you can use to check your work. So we're going to have 3 examples, one for each case, just so you can master how to graph these equations, because that is a very important skill that you need to know. So the first is using a table of values, which is a very straightforward approach. We're given this equation right here, y is equal to x, which is the simplest form of a linear equation. Our slope here is 1, as you can see, and our b value is 0, which means our y-intercept is 0. So we already know that the line, there's going to be a point here at 0, because that's our y-intercept. So I'm going to choose a range of x values, and you can choose any. I'm going to go with from -3 all the way to +3, so that will give me a good range for my line. So what you do is you take your x value right here, right? So for example, -3, and you plug that in your equation for x. So y here would be -3, right? Because I took this x value and I put it here, so y is equal to -3. So this is a very simple kind of equation. Usually you're going to have some kind of operations, right? Like y is equal to 2x plus 2. So you would just take this x value, put it in here, and compute for your y. This one is a very straightforward one because whatever x is, y is just that. So this is your table of values. Just to reinforce that we just substituted this x in here, and then that is what y is equal to. So now we're going to graph this line. In order to graph this line, we're just going to plot these points onto our Cartesian grid. So I'm just going to start by labeling my x and y axis right here. And now we're just going to plot our points. So the first point we have is -3 and -3. So that would go right here. Then we had -2 and -2, -1 and -1, 0, 0, 1, 1, 2, 2, and 3, 3. So now we have all of these points graphed here. So now we can connect the lines and form, the points and form our line. So our line is going to look something like this, and mine is obviously not very straight, but you can use a ruler. And then we will just label it y is equal to x. So I did want to show you how to calculate your first differences, because remember here I said the first differences are always constant. So how you would do that is basically what you would do is you can start from either the top or the bottom, it doesn't matter. I guess I'll start from the top. What you'll do is you can make an arrow like this, and then you will do -3 minus -2. So you find the difference. This is just -3 plus 2, so that's -1. Then I do the same thing. Now I'm doing -2 and -1. So I'm doing -2 minus -1. So that's -2 plus 1, which is -1. So be careful with the signs here. And you're just going to continue that for all of your points. So -1 minus 0, that's -1. 0 minus 1, which is also -1. And then 1 minus 2, -1. And then 2 minus 3, which is also -1. So when we say that the first differences are constant, we are saying that the difference in these y values will all result in the same number. So as you can see here, we have -1, -1, -1, -1. They're all the same. So that's all that means. So now we're going to move on to the next two examples. So here we have a linear equation, and we're going to graph this using the slope y-intercept form. So when you're given an equation like this, the first thing you want to do is you want to write the slope, right? So we know that our m value here, this is in the form of y is equal to mx plus b, where m is this and b is this. So our slope is 2, and our y-intercept is 0, -2. So you can go ahead and actually plot this point right here, because we already have one point on this line. So this is right here, 0, -2. Actually, I'm going to use a different color. So we already have this point right here. This is our y-intercept. But now we want to know, where do we go and how is this line going to look like? And that is what our slope is going to tell us. So if you remember, I said that the slope can be represented as rise over run, where your rise is your change in your y values and your run is your change in your x. So here our slope is 2, and we want to represent this as a fraction. So I can say 2 over 1, right? Because 2 divided by 1 is just 2. It's the same thing. There is a secret 1 here, but again in math we don't write it because we know it's there. So now based on this we can compare and we can see what is our rise and what is our run. So our rise here is 2 units up, right? Because this is all positive. So our rise here is 2 units up, and then our run is 1 unit to the right, right? Because this is our run based off of this, which is just +1. So now we kind of know a direction for this. So let's do that. Let's use the slope. So this is what you're going to do. You're going to start with your y-intercept, and then you know that your rise is up 2 units, and then your run is 1 unit to the right. So your next point would fall at 1, 0. You see how I did that? So we're going to go rise 2 units up, 1 unit right. So our next point is here. And you can just keep on going and continuing this pattern. So rise is 2, run is 1. So rise is 2 units up, run is 1 unit to the right. So now we have a decent amount of points on this side of our line. But what about this side? Like, where is this going to go? So how we do that is we can represent this 2 in another way. And for that, what we can say is we can say -2 divided by -1. And the reason why this works is because -2 divided by -1 is still 2, right? I haven't changed the slope value. I'm just kind of representing it a different way so we can figure out the other direction of this line. Another way to think about it is just do the opposite of this. So if you're going 2 units up, just go 2 units down. If you're going 1 unit right, then go 1 unit left. You can keep that as a shortcut in your mind. If you're a little confused with why we do it like this, that's essentially why we're doing it. And so this tells us that our rise in this case is 2 units down, right? Because it's -2. And then our run is 1 unit to the left, right? This here, this is our run. And we're going 1 unit left. So it is the opposite of this. But the reason why we can do this is we haven't changed the value of the slope because this is still positive 2, and this is still positive 2. So that's why we can do it like that. And so now I'm going to continue the rest of the line. So we're going to go 2 units down, 1 unit left. So our next point would be at -1, -4. Now we're going to go 2 units down and 1 unit left. 2 units down, 1 unit left. And there we have our line. So you can now connect all of the points and you can label your line. So this is y is equal to 2x minus 2. So that's that. And now moving on to our last example, we're going to use the x and y-intercepts. So here you see we have it in this form, 2x plus 3y equals 12. And this is not the slope y-intercept form, right? Because the slope y-intercept form is like this, y is equal to mx plus b. If you want, you can change this to the slope y-intercept form, and then you can graph it using the slope and y-intercept, like how we did here. And I guess I'll actually show you how to do that, because sometimes you might prefer to do that. But first, let's do it using the x and y-intercepts. So given this equation, you can find your x-intercept and your y-intercept. So how do you do that? If you want to find your x-intercept, you set y equal to 0. So you would have 2x plus 3. We're going to set y is equal to 0. Okay, so that'll be that equals 12. So then this cancels. This is 2x equals 12. So therefore x is equal to 12 divided by 2, which is equal to 6. So our x-intercept is at 6, 0. For the y-intercept, we basically do the same thing, except for the y-intercept, we set x equal to 0. So this would be 2 times 0 plus 3y equals 12. So it's this equation, and I have just set the x term to 0. So this becomes 0. Now we have 3y equals 12. Isolate for y, so 12 divided by 3, which is equal to 4. So our y-intercept is 0, 4. And so now we have 2 points on this line, and that's usually sufficient. When you want to graph a line, you basically just need 2 points, because 2 points is more than enough to be able to graph it. So our x-intercept is right here, 6, 0. And then our y-intercept is 0, 4, like this. So we obviously know that the line is going to cross these 2 points like this, right? It's not going to go like that, or it's not going to like curve. We know it's going to go through the 2 points, which is why this works. So this would be 2x plus 3y equals 12. So that's how you graph these linear equations using these 3 different techniques. So I did say I would show you how you can change this to the slope y-intercept form and graph it. So I'm going to show you how to do that here. So you have this form, 2x plus 3y equals 12. And let's say we want to change this to the slope y-intercept form. So the slope y-intercept form looks like this. Y is equal to mx plus b. So we have to isolate y so that it's on one side with all of our terms on the other. So how do we do that? This is all just algebra. So what we can do is we can say this. We can move the 2x to the other side of the equal sign, right? And it'll become negative 2x. So we have 12 minus 2x. And then we can divide everything by 3 to isolate for y, which is what I'm going to do. So divide everything by 3. So then you will get negative. I'm just going to write this term first. Negative 2 over 3x plus 4, because 12 divided by 3 is 4, right? So now we have this equation, and isn't that exactly in this form? Because we have y, we have our m here, x plus b. So now we've done that, and now we want to graph it. So what you do is, number 1, write down your slope. So based on this, we know that our slope is negative 2 over 3. and write down your y-intercept. So our y-intercept is positive 4, so 0, 4. And as you can see, that is exactly what we have here, right? It's right here. So I can graph this method for you with a different color. So I'll do purple, so 0, 4, it's the same point right there. But now we want to use the slope. And what that'll do is that'll give us like more accurate points. So we'll have a bunch of different points. So it'll be more accurate because as you can see, like this line is not straight and we don't know what these points in between are. We just know this point and this point. So now we're going to look at the slope. So write down the original one, so negative 2 over 3, right? And then we want to represent this as rise over run. So our rise is negative 2, which means we're going 2 units down. And our run is 3, which means we're going 3 units to the right. So we're going to use this now, and we're going to go, our run is negative 2, so 2 units down, and then we're going to go 3 units right. So our point is going to be here at 3, 2. So you can see that my line was not that straight because I don't exactly cross this point, but the line would cross that point. So now we can continue. We're going to go 2 units down, rise is negative 2, and run is positive 3. So our point would be at 6, 0. And do you see that's exactly the x-intercept? You can keep going, so you can go negative 2 for rise is negative 2, and run is positive 3. So our point would be here, 9, negative 2. And you can keep going, but that's sufficient for us. So again, now we want to continue on this side, but we don't know where our next point is. So that is your hint to represent this line, the slope, in a different way. How can we do that? We do the opposite of this basically, but I'll show you. So you can see that the negative sign is here at the top, right? Our rise is negative 2. So what we can do is we can write it like this, 2 over negative 3. Because it's still negative, right? I didn't change the value, but now I'm just flipping the negative sign so that instead of the rise being negative, the run is now negative. So this would be rise over run. So now our rise is positive 2. Our rise is positive 2. And our run is negative 3 units to the left. So what we're going to do, we're going to go 2 units up. Let me just move this. So, okay. We're going to go 2 units up because now our rise is positive 2. And then our run is negative 3. So we're going to go 3 units to the left. So our next point would be here. And now we're going to continue. So we're going to go 2 units up and 3 units left. So our next point is here. So now if I connect all of these points, as you can see, it's the exact same line, but we just have more points, so it's a little bit more accurate. And now you can label this as y is equal to negative 2 over 3x plus 4. So now I've shown you how you can use the slope y-intercept form for this as well. It gives you the same thing. Notice that the slope is negative, so our line is going like this. It's going from the second quadrant to the fourth. So it's pretty straightforward. Just practice and get used to it. Do more practice problems. And if you have any questions, feel free to email me or leave a comment, and I will do my best to answer back to you. And yeah, I'll see you guys in my next lesson.